In this video, we'll be demonstrating the direction, magnitude of electric field due to point charges, and also will introduce you with the concept of null point, how field changes, how it behaves in the presence of two charges. Okay, so on the screen right now you are able to see a point charge which is a positive point charge and its field is radially outward. Okay, so now I'm going to put a I'm going to bring a test charge which will give you the direction of force, or we can say field, as well as the magnitude of field. Okay, so let's say this is the test charge. Okay, so the length of arrow is the magnitude of field. If you can see very carefully, as I'm moving this test charge towards the positive charge, the length of arrow, which is the magnitude of field, is increasing exponentially. Okay, and as I'm moving the charge away from the original charge, its magnitude is decreasing. Okay, you can see the values also changing. Okay, let's put it here. Again, you can see the direction of field is radially, and it is quite high when I'm close to the charge, and it is quite low when I'm away from the charge. Okay, got it? The similar analysis can be performed with the help of a negative charge. This blue charge is negative and this yellow dot is a positive test charge. Again, the field due to the blue negative charge is shown with the help of these arrows, and the test charge is experiencing some force, and the magnitude of field is given by again the same red arrow. As I'm moving close to the charge, the length of arrow increases, and if I'm moving away from the charge, its length decreases. The direction is always radial no matter where I place the test charge. Okay, so I can say the field of negative charge is towards the charge no matter where you place the test charge. It is very high near to the charge, it is low away from the charge. Okay, now we'll look at the fields of two charge system. Okay, so these are two equal charges. This is our test charge. Again, when we are on the right side of the right positive, the field is very high. Again, the field is very high near a charge, and as we move here, this is an interesting point. So what is this? We are not experiencing any field here. So the net field, we can say, is 0 at this point. We call this point as null point. Null means 0. Okay, so 0 field point is a null point. And as we move away, the field of this charge start dominating. Okay, and if we are on the right side of null point, the field of right positive charge dominates. Okay, so the net field is towards left, and as I move here, you can see the variation of field due to both the charges. The field diagram on this page is the net field diagram. Okay, so the arrow represents the net field at various points. You can have a look. Null point, the field reverses its direction, become very high, again reverses its direction, and start decreasing as I move away from the system of charge. Now I increase the magnitude of this charge. Okay, so the charge on the right side of the page is quite heavy or quite of large magnitude as compared to this charge. And an interesting thing you can observe, that null point is not exactly in the mid, it is somewhere close to this point. Okay, so here is the null point. Oh, this is the null point. Oh, let me this is the null point. Okay, So you can see this distance is much larger as compared to this. So null point, another observation you can take, null point resides near the smaller charge, okay. Now we are looking at the system of positive and negative charge, okay. They are unequal in magnitude, obviously different in sign. So this positive charge has a much higher magnitude as compared to this negative, okay. This is what I put values, okay. So you can see the field of positive charge dominates near the positive charge, obviously it should, and in between the charge the field is not changing direction because both charges has field in same direction. Positive charge away from it means towards left, negative charge towards the charge means again towards left. But as I crosses the negative charge, initially when I am very close to this negative charge, the field of negative charge is dominating, so the net field is basically towards right side, which is towards the negative charge, okay. But as I move away, the field suddenly decreases and I reaches a null point. For opposite polarity charges, null point resides outside the charge system near the smaller charge. Negative charge is the smaller one in this case, okay. So this is the null point. And another very interesting point, what happen if I cross the null point and move away from the charge system? The field again reappear and the system is now behaving as an effectively positive charge system because the magnitude of positive charge is higher than the negative charge. So the net field at this point is predominantly decided by the positive charge, which means the field is away from the system, okay. And if I move further away, the field start decreasing as the distance increases, okay. So there is a point where this field becomes maximum also, okay. So that is another observation we'll talk about later in terms of potential, okay. Null point, again outside the system, null point if charges are opposite polarity and near the smaller charge. Negative charge is the smaller charge in this setup, okay. Again, now you can have a look at just opposite system. Negative charge is of higher magnitude as compared to positive. We are finding null point near the positive charge somewhere here. And if I move further, the field start reappearing and the system start behaving as if this is an effective negative charge, okay. So the field comes towards the system or towards the negative charge, I can see, okay.